Hello everyone, my name is Skodje and today I'm going to show you how to make KinematicBody2D player controller. Now, when you're creating a player in Godot engine in 2D, usually, or rather 3D as well, but in this case we're going to talk about the 2D one. When you are deciding to create a player, you have the option to choose between Rigid Body 2D or Kinematic Body 2D. Now, the difference between those two is that Rigid Body 2D is used when you want to interact with other objects affected by physics. Now, an example might be if you wanted to make a ragdoll that had movable parts upon death, or if you simply want your player to directly interact with other physics objects around you, such as moving rocks that are on the ground. As you walk on them, they move around. Selecting a Rigid Body 2D gives you additional properties that you can change, such as mass, weight, friction, gravity scale, and so on. However, in Kinematic Body 2D, you will have to manually create them. Now, that being said, I prefer Kinematic Body 2D as it gives me the control to set whatever laws of physics I desire as a programmer. Now, setting up a Kinematic Body 2D is not as difficult as you would think. In fact, I think it's easier than setting up a Rigid Body 2D. So, I'm gonna create another video in the future where I show you how to create a Rigid Body 2D player. But in this video, I'm going to demonstrate to you how to create a Kinematic Body 2D player controller. Whew, that's a mouthful. I've already prepared a new project which is completely empty, and I will walk you through it. Now, I'm going to start by creating the scene control. If you want, you can skip ahead to the part where I actually write the player controller. In the beginning, I'm going to create a TileMap in order to have a level to interact with, because as a player you would want something to stand on. Okay, so these are the tiles we're going to be using for this example here. We have the normal floor tile, which is just horizontal and easy to move around. We have a bumpy tile, which we're going to use to demonstrate some weird issues you may get with jumping if you don't do the fix I'm going to show you as well. And we have a slope. And in our tile map, we're going to load our new tile set, which we just created here in the export folder. There we go. Let's create the floor here, but the size is wrong on the cell. So let me change the cell size to 32 by 32. And let's draw the floor here. There, perfect. So if I were to play this now, I'll have to select the main scene as the one we're gonna use. Hit play again, and we now see floor. And these floors have collision in them. Let me create some bumpy textures here. Let me create a slope right over here. There. 1, 2, 1, 2. There and there. We'll just add this under here to have something solid there. I know it doesn't look quite right, but that's fine for this demonstration. We now have our world. Let us start by creating our player here. On the main root node, I'm going to create a Kinematic Body 2D. This will be our player. So what does a player need? Well, we need to see the player, so we will need a sprite. There it is. Now, I already prepared a sprite character as well, or rather, I have a friend of mine that managed to make a nice and simple looking character for this demonstration. Thank you very much, by the way, if you're watching this. Let's go out, go into the player folder, which I just created on the side here, and select the player here. And there he is. Let's move the player down a bit here. If I were to play, nothing will happen, because this is a kinematic body. Now, I feel it's a bit too small here, so let's add a camera here. Let's create a camera that follows the player here. So let's create a camera 2D. That's the one. Let's rename this. Okay, so we have a camera here, but it's not being used there. The camera is the one with the purple edges here, which you may or may not see. Actually, yeah, there it is. Is it purple? Yeah, it's purple. The blue one is the main. Wow, it's so many colors here. Okay, let's just fix this here. We want to set the camera as current. That's the first thing you want to do when you want to use this. Ah, there we go. Now you see the camera edges here. That's better. And this is centered up on the player here. But it's still too far away, so let's zoom in there. Let's zoom in to 0.5, 0.5. Let's take a look. Yeah, that's much better, right? Now you see the player. Okay, what else do we need? Well, the player will need a collision box, otherwise when we implement gravity, it's just gonna fall through here. So let's start by creating a collision here. Collision shape. Let's start with shape, yeah, that should be fine. we don't need to be that detailed. So let's just create a shape here. Select a new capsule shape. Yeah, perfect. Let's select the width and height. It's a good width. Let's do it higher here. Now we don't want the floor, we don't want it to be like this, because then 1 foot will be in the air. So let's make it like there. Yeah, that's good. Let's Control S to save here. Okay, we have all the parts we need in our node here, in our player node. Now we created a KinematicBody2D. We have a sprite, we have a camera that follows the player, because it's a child of the player, so it'll automatically follow. And we have a collision box, so he won't fall through the world. Okay, let's right click player, create add script. Let's select the player folder, let's create a new player script called player. And create. Okay, so what we need first is a gravity constant. So let's create laws of physics. Sounds fancy, right? But there's nothing fancy about it. It's very simple. Gravity will be a vector that will be pointing downwards with a force of, let's say 400. Okay, what else do we need? Well, we are going to need a velocity player variables. So we have a velocity that changes, so it's a variable, it's not a constant. Velocity is also a type of vector. Now you don't have to do this, create an empty vector2, but it helps doing so, so you know immediately that this is stored as a vector2 somewhere in the code. Okay, and ready. Well, the only thing we're gonna do here, we're gonna enable set fixed processes to true. Now, fixed processes are run every frame. It's fixed. Let's create some comment here. Start. And let's create our processing. Func fixed process delta. Delta is the time between each time this runs, which is very, very small. Because this runs pretty fast. So let's add gravity here. We have velocity plus equals gravity times delta time. So basically it won't instantly increase, but it will gradually increase with time. Okay, so we have gravity in a velocity, but how do we get it? How do we make the player move? Well, if you're using an old Godot engine version, you can use move. So let's try it. Let's add a move. Let's add velocity here. Let's take a look and see what happens. I do suspect it's a bit too much here, so let's reduce it to 5 here. Hit play. There we go. He fell down onto the ground here. Okay, but we are going to use something more awesome and easier to use. Make sure you're using at least, I believe it's 2.2. I could be wrong, but just use latest version and you should be fine, hopefully. Now, if by any chance 2.1 does not have this, I recommend you browse the forums and see if you can find a nightly build somewhere. Anyhow, let's create, I'm gonna comment this out, old. New. And this will be a move and slide function, which is amazing. It makes life so much easier. What does it need? We need a velocity. We need a floor vector. So let's create that. Floor vector. What else? Well, we need a float slope stop min velocity. It's basically, it means friction in a way. So let's call it slope friction. We don't need the last one. Okay, let's create these constants. Movements, constants. Const, floor vector. Actually, why did I write vector? I want a normal, floor normal. There we go. Now this is going to be facing upwards, because that's the opposite direction of where we are going to stand. No, wait. Yes. That's right. I have to think for a moment there. It's upwards. -1 is up. Because when you go down in the Y direction, you go up. When you go up, you go down. When you go up, when you go in a positive Y direction, you go down. Oh jeez, I had to wrap my brain around that for a moment here. Const, there we go. Now we need the slope friction. Let's put it to 20. Now we may or may not have to... What's wrong? What's wrong? What is wrong? Hello? Oh, I see wrong here. There we go. Yeah, I didn't see anything wrong. I mean, if I haven't seen this, I would have known this is correct. How can this be wrong? There we go. Okay. Anyway, let's try it again. Oh boy, that's so slow, but you can see him gradually increasing. That's because of this. It gradually increases. And that's the way we want, but we want it to be fast. I want it to be nice and quick. Just boop. Okay, that's a bit too slow. Let's try 500. That's better. Let's stick to 500 here. Okay, now we want to store this, the value. So I'm gonna add velocity is equal to this. Okay, so what do we want now? Well, we want to get the input, right? So we're gonna need a movement variable. Now, movement will change to be +1 or -1 depending on the direction you're going, horizontally speaking. So if input dot is action pressed, because we want it to keep moving while you're holding it. Let's just use UI left, because then we don't have to configure anything else for this video here. So if you're pressing the arrow key left, we are gonna change movement to minus equals 1. But, or rather and, if input is action pressed UI right, we are going to set movement to +1. So if you by chance are holding both left and right button at the same time, or rather the arrow keys at the same time, you won't be moving, and that's what we want. So let us set the movement now. Well, this is the, I guess you can call it the speed or the velocity of our movement. So let's just multiply movement with a generic movement constant. Let's just call it movement speed, I guess. And let's create this constant here. Let's go up there. Let's put it on top of there. Actually, no, let's do that one here. Const. Movement speed equals to how much? 400? Might be too much, it might be too little, I don't know. Let's find out. Okay, we are almost done with movement. So what we now is, we want to change the velocity in the horizontal direction using the movement variable which we just set now. So what we do is change horizontal velocity in x direction. I mean, that x is horizontal, just velocity, let's just stick to this. So we have velocity dot x. It's going to be gradually changed using a lerp. That's a funny thing. It normalizes. How do I explain this? Let's see. Did I have it here? Lerp. Ah, there it is. Linear interpolates between two values by a normalized value. Yes, there it is. I couldn't have explained it better than myself. But basically, it makes so x velocity gradually changes to the speed. So let's first start. Let's get the current velocity which we have now in x direction. That'll be velocity x. There we go. Now we have a new movement force, which we're gonna add there. And lastly, we're gonna add acceleration. So acceleration. Now this is a constant we're gonna make. Basically, the lower this value is, the faster it will move. Actually, I'll just show you that instead of trying to explain. Oh, const acceleration 25, 2.5, 0.5. Let's try 1 first and see what happens here. Okay, I think that should be it now. Let's see here. Yes, we are now ready to try and see if we can move our player horizontally. Play. Whoop. Oh, it works. Sweet. Boing, boing. Woo. Okay, the gravity is a bit weird there. It's a bit too low. Let's increase it a bit. Let's try 1,000. That's a little better. It looks a little bit more realistic, right? A little bit. Yeah, I like this. 1,000 is good. Okay, so what now? What fun is it only moving horizontally? We would like to jump, right? So what do we need to jump? Well, we will need to know whether or not he is grounded. So let's start by creating a boolean. So var can jump. Now by default, you cannot jump unless this changes to true when you are on the ground. So let's use this. Let's go down here. Let's see here. Velocity. Let's put it between here. Yeah, this is the input area, so let's put it here. So if, or rather, let's just can jump is equal to is move and slide on floor. So if I am on the floor, this will be true. And we will be able to jump. Can jump. Question mark. That's good. That's a good comment, right? So at the end there, we're gonna check for input jumping error. So if can jump is true and we are pressing the button which we want to press to jump is action pressed. Let's see here, UI up. So when you're holding the up arrow here, we are going to jump. Let's try it out then. Let's try it out by setting velocity in the y direction to minus equal some jump force. Jump force, I guess. Let's add a constant called jump force here. Let's try 200. Let's see, if I can jump, we need to make sure to turn it to false here, so we can't keep jumping. There we go. Boing, boing. But we're jumping a bit low, right? So let's add a little higher. Because gravity is a bit high too, so we want to jump higher. Let's try 500, see if that works. Woo, that's better. But a bit too high. Let's try 300. Yeah, that's a bit. That's good. Boing, boing. Now, here's the problem. So if I were to move in one direction and press jump, if I press jump the moment I am bouncing and in the air, I will not jump. That's because when I'm in air, it's triggered as false, so it won't allow me to jump. So basically, I want to add a small time tolerance, I guess you can call it, that I'm allowed to jump even though I'm in the air. So for example, if I'm in air for like 0.1 second, I should be allowed to press the jump button even though I'm not technically on the ground. So the way we do that is by creating a new variable, jump timer. Let's call it jump timer, yeah. Set it to 0. But we also need a jump constant, so let's create a constant jump time threshold. So let's be allowed to jump if the time you're in air is less than 5.5 seconds. It's a bit too much, we'll change this afterwards, but it will be easier for you to see it when we do it here. Okay, so the thing about jump timer, we wanted to increase every time this runs. We want the time basically, and we do that by adding jump timer by plus equals delta. So it will increment. Now, the way we're gonna do this, we're gonna change can jump. We're gonna add this inside an if statement. So if I'm on ground, the jump timer will be set to 0. Because we will only be allowed to jump when the jump timer is less than the jump time threshold, which means we don't even... Hold on, we don't need to change this to false here. It means we can just change jump timer to the constant here. Because then it won't, every time we jump, it won't be less than this, and we can't jump again. Because if we don't do this, we can jump 2 times, if you are jumping again within a certain amount of time. And that may be the effect you want. Maybe you want a quick double jump. But for now, we don't want that. So if we can jump, it needs to be changed to can jump each time jump timer is less than the jump time threshold. So if this is less than this, we can jump. So I'm gonna move this in jump timer controller, I guess. We can jump. Yes, now it should work, hopefully. So you can jump through. Yeah, there we go. Okay, let's try it out. There we go. Yeah, you see it there? Whoop. Let me add a block so you can see it clearly here. Perfect. Now I have a small threshold that allows me to jump even though I'm in the air. Now 0.5 is a bit too much. Yeah, it's a bit too much. So let's change it to maybe 0.2. Let's try 0.2 here and see if it works here. Now I'm jumping a bit low, so I'm gonna increase the jump force as well. Let's try 400. That's a little better. Now you can see it a bit clearly here. Yeah, perfect. Now I can jump every time. Now you may notice that my velocity adds up with the jump force. So I can take a running start and jump higher than I could by standing still. As you can see. One last thing before I forget there. Now I did mention the acceleration here. Acceleration 1 is pretty much instant. As you can see. There. If I were to reduce the acceleration to 0.3, for example, you will notice it's a bit smoother. Let's try to reduce it to 0.1. Yeah, whoa, it's like I'm sliding here almost. But as you can see, it's much smoother here. So, just change it to your liking. Now this is all tweaking. Now I enjoy responsive controllers because I don't want the player to feel as if the controller is not intuitive enough. Like you pressed it, but it's just too slow, and yeah, we don't want it. Whoa! I'm going to add, of course, a written tutorial on my website, where you can find this code along with some simple explanation what it does. The source code for this project will be available in a download below. I'm also going to include this on GitHub if you want to take a look at that. If you enjoyed this video, hit the like button, subscribe, and I hope to see you in the next video. Bye bye!